Today, I'm going to show you some tips and tricks to get your Homelab networking sailing. And we're going to be talking about 10 gigabit, 40 gigabit, 56 gigabit, and 100 gigabit, and some of the things that you want to watch out for so that you don't end up creating a bunch of waste. That was close, like I just did. So I've been melting transceivers for the past couple of days here, and I thought this would be a fun time to get you involved because I've also been going really fast. And I've learned a lot about troubleshooting that I wanted to impart just a few of those things to you in case you run into the same problems that I am running into. So we'll start out with talking a little bit about 10 gigabit, whether it's fiber or whether it's Cat6 based, is something you should definitely have as a baseline for your home lab. The reason why is because you're going to be able to saturate that with almost every machine out there now, and 10 gigabit networking is actually surprisingly cheap. Next up, 40 gigabit. So when you're looking at 40 gigabit networking, you have a pretty big step up. But this is also something that almost every system out there will be able to utilize, and you probably can get speeds that are in the low 30s to high 20s, definitely over 25 gigabit. Now, 25 gigabit is kind of a standard that a lot of people recommend. It does come at a bit of a price if you're looking for a large multi-port switch. I know Unify has quite a few of these. There are a couple others out there, but if you're looking in enterprise and X-enterprise gear like I like to do, then certainly 40 gigabit and Mellanox is kind of the way you want to go with something like a 6036 and Connect X3 cards, both of which are incredibly cheap. As well, DACs for those and also fiber and transceivers are really cheap for 40 gigabit gear. Little bit step up, 56 gigabit, still in the 40 gigabit class, enabled by your switch, a Mellanox exclusive feature. You want to get the Pro CX cards. This is just a Pro CX card, and there is a difference, so do make sure you check the links below if you're looking for those. And finally, we'll round out by talking about 100 gigabit. So I'm going to show you that today as I've been doing some 100 gigabit-ification and some of the pitfalls that all of these cards are going to have that you better be aware of if you're going to get into this, because you're going to end up like I did, melting a bunch of gear. Let's get started. Switch that we've got on the lower area here that has most of the fiber connected to it, and you can see some DACs connected to it also, is the Mellanox SN2700. And this is a really good switch for being able to run 100 gigabit networking. It is a little bit on the loud side. Above this, you can see a Mellanox SX6036. This one is kind of a standard. These are very cheap, and they really can move quite a bit of ETH traffic or InfiniBand traffic. The SN2700, you're going to be only using ETH traffic on that. So you might think that you wouldn't be able to get 100 gigabit networking in a small desktop. And unless you add airflow to it, you would be right. But that also applies for 10 gigabit and 40 gigabit networking. Those cards run hot. You're going to need to add some additional cooling fans. So on this machine here that I've got, which is a Dell 3620, this is actually a Xeon or i7 capable machine, and you can see that I added a fan to the perforation that they had on the side here. So this is something that you can get a splitter, add in, and then you can add in your 100 gigabit NIC and get direct airflow. It doesn't take a lot to keep it cool, but you definitely have to have some forced airflow. One of the other things that you want to do, and this looks silly here if you see this, is you want to add little heat sinks. And this is silly. I know this looks pretty crazy, and it is crazy sharp also. And I also burned myself when I was doing it. But this heat sink is keeping this transceiver from melting itself. And when you're moving a lot of traffic, that's going to get hot. And I mean really hot. Hot enough that after a few minutes, it's going to melt itself. Now, the transceivers I'm using for this are very cheap, but the flip side of that is they are also very hot. So Intel put out quite a few years ago some really nice optics that were meant for data centers where you're going to have high airflow and tons of cooling. So these CWDM transceivers do need single mode fiber. So OS2 is what I'm using here today, and that actually you can get really cheap. And these you can get really cheap as well. However, if you're inside a rack and not spanning outside of the rack, I would seriously recommend going with a good quality DAC. So I decided to test all of the cables out, and I've hit quite a few fiber cables that had packet loss, and many of them actually just kind of had separated from the boot. So another thing you want to be really careful of is your bend radiuses, because if you are looking at a switch and you've got a bend coming into the front, that definitely puts strain on it, and the next time you move it, you might find that the boot has unseated from the back end of the cable, and that exposes fiber, and it essentially ruins that cable. And so this Dell 3620 has been running really good since I put this fan here, and I've got down here an A4000 GPU. Now this does downclock as it's on a smaller bus width, and also where you're running an i7 in here. But between these two, this is able to negotiate at a full 16x whenever it needs to. And since I'm just mainly doing inference workloads that don't require full PCIe bus saturation, the A4000 is doing great. You also see that I've got a 2.5 gigabit NIC here. That is my WAN uplink that I have floating between all my Proxmox machines as a virtual machine. Really great and provides me with good speeds. So this has been running really solid and really good, and it's amazing how much you can get performance-wise out of a super friendly to the pocketbook kind of computer. Next, we're going to look at something a little bit cheaper even, but I'm going to show you one of the problems that I hit, what some of the symptoms look like, so that you can see if you're running into those problems, what you need to do to troubleshoot. So troubleshooting is hard, and I thought that was probably one of the biggest things that I wanted to impart today is how I went about troubleshooting to find out this specific problem. So if you're looking at a modernish GPU, you could have 16 Gen 4 lanes, and that gives you an amazing amount of bandwidth. Now, one thing you'll notice if you're looking at something like a Mellanox Connect X4 or Connect X5 is that they're full 16x width. These come in Gen 4 or Gen 3 capabilities, but that definitely impacts the number of ports you'll be able to run at full speed. So, one 16x at full speed, you're going to be maxing out your 100 gigabit connection. Now, they do have dual port variants of this, but keep in mind that your 16x at Gen 3 speeds does not support 200 full gigabits of speed. So that's one thing to factor in when you're looking at really high performance cards. Second, because they can downgrade, you need to be able to check this. So here's how you check this with LSPCI. So this is going to give you a lot of detailed information by typing LSPCI VVV, and this command gives you very, very verbose information about each one of your connected PCIe devices. Now, if we look at something like a CX4, you can see that right here we're negotiating at a full X16. So this is a consideration that I made with the desktop class systems that I'm putting high performance networking in, is to put those in the top slot. Usually the top slot on something like a Dell is going to be the full 16x negotiation, and there's not going to be manual bifurcation settings. However, you may have the settings in motherboards that allow you to do that. Do need to check and make sure that you're electrically capable of supporting enough width and enough generation. So if you have 8 width at Gen 4, that's essentially the same as having 16 width at Generation 3, aka enough for a 100 gigabit network. And most of the time, you're not going to impact your GPU performance by going to a X8 versus an X16. So that's something to consider. You'll notice here on the GPUs that I'm showing here that they are actually all the way down to X4. Now that's fine because I'm not doing bandwidth intensive high performance compute operations with them. I am doing inference workloads with them, but that's fine even all the way down to X1 at Gen 3 PCIe speeds. So now you know how to check, and especially keep in mind if you see that you're hitting 25 gigabits and you seem to be limited but very consistently at 25 gigabits, maybe 26 gigabits also, that's very likely an indication that you're being PCIe bandwidth limited. So make sure to check that with LSPCI-VVV. So you're going to notice I've got little heat sinks that I salvaged, and I'm going to show you where I'm getting these from just in a second. And you can also find them, of course, on Amazon if you want to go the easy route and buy them. But if you're into getting your Dremel out and cutting up a bunch of unused heat sinks, which I think is a great thing to do, then you can just use some thermal pad to adhese them to this. However, I chose to try this out and it was already too late. So it comes down to a big problem when you have a transceiver and fiber, because the question starts to be, which thing failed? Was it the card? Was it the transceiver? Was it the other transceiver? Or was it the actual fiber? So figuring that out is a bit of troubleshooting, and one of the reasons that even if you are going to go all fiber, you should definitely get at least one DAC for whatever type it is, 10 gigabit, 40 gigabit, or 100 gigabit networking. And so one of the most unlikely pieces of hardware to see a 100 gigabit network in is about $100-ish mid-tower that is not big at all. If you'll notice, I've got this fan that I just rigged up with some zip ties, and it does a great job of keeping not just the Mellanox 100 gigabit networking card, which you don't have to put a 100 gigabit network in here by any means. But if you do put a 10 gigabit or a 40 gigabit or a 25 gigabit or whatever, you definitely want to have auxiliary cooling for it. So fixing a fan up like this, I do have to open that to get it in and out, but that's it. And down here underneath that, I've got a Tesla P4, which is a great 8 gigabyte card that also makes use of this fully. And I've also got a 2.5 gigabit NIC in here. This is actually loaded up and a really, really cheap way to get some pretty decent performance. And the reason why is because it has a great single thread speed for the processor that came with it, which is a really decent i7 7700. So that right there allows you to go faster if you're looking at ETH traffic, which is single thread bound. Of course, you can use things like RDMA. It's a lot of extra configuration. I'm sure we'll have some videos on that. But if you're looking for the easy route, ETH is the easy route that you're usually thinking of. And I'm going to talk about some of the constraints and why you want to bound it to those constraints. And you don't have to overshoot and go crazy on one thing. You should try to balance out your entire network and the performance that you're looking for, especially for things like shared storage and remote access to virtual machines. And of course, all of these things are in the links below, and you should check out the channel history where I introduced these into the equation and the testing and other things that I've done on them. All of these machines have been featured before. Right now, I've got the DAC in here, and this DAC is much less likely to present an issue versus a piece of fiber and also a transceiver. So that was, of course, my biggest concern, because the Mellanox CX 400 gigabit cards are, they're not cheap, and I don't want to go burning through them. And this definitely, with this setup here, has made it such that I don't have to worry about burning them up. Good airflow on it. Now let me unplug the DAC here and plug in the fiber, and I'll show you what the problem was and what you should be watching for. If you're noticing that you've got some weird behavior, test these things out immediately whenever you get a new piece of hardware that's an old vintage piece of hardware, because you got a limited return window. So make sure that you get this tested as soon as you get something like an upgraded network card. And one additional thing I plan to do is to drill a circle and put a mesh so that I can get good airflow into the fan that comes from the side of the enclosure. I don't know what it's going to do. This is actually pretty thick metal, but I'm going to grind it down or figure out how to get in there somehow. So wish me luck on that one, but that should give me really good airflow directly onto the 100 gigabit NIC and also the GPU. So Proxmox 7 over here, you can see that denoted by this, is the one that will present the problem. So we're going to use a tool called iPerf 3 today, and there's also another version of iPerf as well if you want to test multi-threading. iPerf 3 is great for single thread testing though, so I would recommend considering that. On Proxmox, I've already got it installed here. The next thing is you need to run one as a client and one as a server. So Prox 6 is the other one we'll be testing. And if we come over here, you can see that Prox 6 is a i7 7700K and Prox 7 is an i7 7700. There is a difference in the gigahertz max thread speed of 3.6 to the turbo speed of 4.2 that you have on the i7700K. That actually is important if you're looking at ETH traffic. I'll show you guys why here in just a few seconds. But let's go ahead and set this test up. So I'm going to run the server, and that's done by just doing iPerf 3-S on Proxmox 6. It'll say that it's listening on, and it'll give you a port. Then come over here to Prox 7, and the next thing that we're going to do is type in iPerf 3 and -C. That means client, and you're going to be connecting to the IP address that is running on your server that is hosting this. Once you hit start, you'll see that we're hitting right around 40 gigabits per second here. And everything might look like it's doing okay, but we're going to give it just a few minutes here by doing a T and 120. And we should see the error pop up. Now you can see we're hitting consistently between 37, maybe 40-ish, but it is somewhere in that neighborhood, gigabits per second. That's around 4.5 gigabytes per second. And when you're looking at this, you want to size it up to your storage as best as possible. But the most important thing is to test it out, make sure that you've got a stable connection, because you don't want to have something dropping and restarting in the middle of it. And that's definitely what I think we're about to see here start to happen, as we see some of these speeds coming down a little bit as there is thermal pressure on the transceiver as well as the card, as it is heating up as it is pushing packets through the stack right now. I think we just saw it there. It looks like it stalled out here. Let's check the other side. Okay, so that right there is what I was talking about. That drop is due to one of the transceivers overheating before I put the heatsink little head unit thing on it. So, okay, and so it'll cool back down and then it'll kick back up. So that transceiver is blown out. So definitely don't let these, if you end up going with high performance networking, and you're buying transceivers and fiber, don't let them ever get hot. It's a great idea to just get a little, piece of heatsink and get it on there from the first time you try it out, so you can't induce damage. Again, most of this gear was built to run in very cool, very high forced airflow environments, and in a desktop case, you don't get that. And especially at the back of a desktop case, you may not have very much wind pressure at all. So it did finish up here, but definitely that pause that you see here is a lot of disconnected state, and that's not good. So we're going to take this piece of fiber out, and that transceiver is bad, but the fiber cable itself is good. I tested it on a different setup, and we're going to put the DAC in to test against it. And so now we're going to give it a test out and just see if it's stable now that we've got the DAC in there. And you can see that the speeds are much more consistent also that we're seeing out of it. So I have a feeling that it's going to be quite a bit better. If I'm looking at the retries here, it looks like we had one retry there, but pretty consistent in the mid 30s. Now with 40 gigabit networking, you should expect to be able to hit somewhere in the about 32 gigabits per second. There's a bit of overhead, especially with ETH, when you're looking at 40 gigabit networking. With 10 gigabit networking, somewhere around 9 to 9.5 gigabits per second is going to be where you're going to top out. With 100 gigabit networking, you're usually going to be limited by what your single thread speed is on an ETH connection. So on something like a 4.2 gigahertz i7 7700K, you should be able to theoretically hit somewhere in the ballpark of about 42 gigabits per second. However, if you note, the i7 over here has a thread speed of 3.6, and that is going to limit things down quite a bit as a result of that. It'll be somewhere in between those two typically, what you see, but 3.6 is probably going to be the upper limit as long as I'm using that. So you can see that we didn't run into any timeouts here on this next try, so really stable, consistent connection, which is exactly what you want.
While you can buy yourself heat sinks, sometimes you might have some gear laying around. I have this old SAS HBA. These are QSFP. It is a net app. It stopped working, never really worked that good in the first place. And just popping these off and giving myself a little bit of time with the Dremel, I was able to make quite a few really good heat sinks here.
And I'm probably about 2 feet from the front of it. If you can keep it at about 75 degrees Fahrenheit or about 24 degrees centigrade. This is at the front. And it's much louder in the back. This is about 2 feet away. And the 5548P gigabit switch is also running. Definitely louder than most modern switches, but still not horrible. And that's at the quietest fan level. If it gets above 75 degrees Fahrenheit or about 24 degrees centigrade, the noise level goes up quite substantially. So it must be kept in a very chill environment. And you can see the temperature status there. When you're looking at the front of it, that's sensor A2 and sensor A1 is the rear. So just a little bit of a difference there, about 0.5 centigrade. And I'll take a second to show off the new paint job. I think it looks pretty good. And currently the R720XD is running a single 100 gigabit network connection, and that's at 9,000 MTU on the card inside my TrueNAS. It does definitely make a difference if you're running 9,000 MTU, but you definitely want to run 9216 on your switch if you have all Mellanox gear. That does vary from independent switches to independent switches, but definitely on your switch, having a larger size max MTU will allow you to fit smaller sizes like 9,000 in it with whatever additional overhead there is easily. And let's see what the Windows desktop can get running against the server. And this is going to be replaced very shortly with the new storage server build that is going to have 2 NICs in it bonded together with LACP. And that is a pretty IO heavy configuration. I'm going to add an additional 100 gigabit NIC in there, and we've got quite a few SAS that will be used to connect to the JBODs as well, and of course ultra high endurance NVMe. And so whether you're running 100 gigabit, 10 gigabit, or 40 gigabit, the ConnectX lineup is still a really good value for Homelabbers. These are very, very affordable cards, especially the CX3 lineup now. The CX2, which is a 10 gigabit, has been very affordable for some time. Be sure to check out the article that I've got written on the website for more information about all of these tips and tricks that I've got for home networking that is high performance specifically, because it's kind of hard to find that information out there. So I'm happy to share it, and I do look forward to reading your comments below. I need more OS2. At least it's actually come down in price quite a bit. And we got another heatsink on one of the transceivers here. And this is going on the quad GPU rig over here, which I also added some fans to the front so that it does produce airflow that is pretty decent. You know, you can barely see that. Airflow that is pretty decent over both the RAM and also the network card. And another tip is don't throw away your tip covers. If you ever need to run this through a new location, you definitely want those tip covers back on it to provide protection to the fiber optics inside.
And so these tips work for any fiber installation. OS2 multi-mode, they're going to have fairly similar characteristics when you're running them. It does help to have a second set of hands, but if you don't, having ample amounts of Velcro can be really helpful. You can kind of loosely adhese it together and kind of use it as a pull away. So when I pull on it there, it'll break off, and I can pull it up gently onto the top of the rack. And we're going to run it from here up into the raceway. And this is some great stuff I got just by being bold enough to ask when I picked up my server racks if they had anything else they would like to get rid of, and boy, did they ever. So I've got this actually supported by, I think those are bicycle holders. They're very cheap, and it's worked out incredibly well. Now, the raceway is actually pretty expensive. If you were to buy it yourself, I would actually think you might be better off going with something I'm going to show you here in just a little bit. If you're looking for a support for doing some running of cables, and they're going to be up kind of higher, some closet rack is actually something that's pretty darn easy to get, very easy to install, and significantly more cost economical. I like to use gravity also when I'm doing these runs because it keeps tension off of the cable, and especially if you have any sharp edges anywhere, you definitely want to just let it go easily through. So got a nice piece of conduit here that runs into the structured media panel. Of course, you can watch the channel's history to learn more about that installation that I did from scratch for you guys. And we're gonna just fish it out really gingerly and just let gravity pull it the rest of the way as much as possible. Got to give it a couple little pulls there to get it through. Got a DIY loop for my fiber, and this has really been working out well. You could probably 3D print something or buy something better than this, but just mindful of the bend radiuses and not to go crazy on tensioning it. Yeah, got enough slack there. And your installation's going to go pretty good. So there's our run through the DMARC and spanning up to the Dell 7050. Put a new heatsink on a new transceiver here, so hopefully I don't end up burning this one up like I did the other one. And this time, I think we're going to be in luck. I've tried out some of these heatsinks on some others for running very, very long tests on moving packets, and they have performed really good. So definitely make sure that you have forced airflow on the inside and also heatsinks on the back. This is exactly what I was talking about when I said using some of that closet rack material that you can get at a home goods store. So this one here is running over to the other table. And let's go ahead and get the 3620 slid in down here on the bottom shelf. The storage server is getting dual QSFP28s for network. And I've got two SAS HBAs that I'm going to get connected up here, and a tape library that I'm connecting to the single one there. And while the DACs run much cooler, and I don't think that I'm going to run into a heat issue with them, I'm just going to go ahead, since I made so many heat sinks earlier, and put some of this owl tree thermal pad on some of those, and just for good measure, have the DACs also have a little bit of a heat sink on each one of them. Those are actually pretty big little heat sinks, but they work, and I'm not back there very often. All right.
And we're going to pull this across the raceway the rest of the way here. Very gently. And I've got it kind of slacked up in the back in one giant loop, flaked out so it's very straight when I pull it through. And just pulling it real slow. It feels about like some tension there, so I'm going to go check that out real quick.
And this is, of course, that really cool, really cheap, held up by really thick zip ties, 3 on each end. And it was an 8-foot piece. It spanned perfectly between the garage door hangers, whatever those are called. And those hangers I also covered with just pipe insulator, very cheap pipe insulator. I think I spent all of a couple dollars on that pipe insulator. And I just take my time. Going to have that second run now of OS2. So 200 gigabits of capacity over here. Actually, OS2 is capable of even more than 100 gigabits. So in the future, maybe I get even more out of it. But for now, it'll just be 200 gigabits. Just gently finish running that over. And yeah, I like the new pegboard area that I've got also for holding cables. Got a lot more cables to put up there, though. And yeah, so there we go. Now we've got 2 spans for 2 different machines.
Cool. So I've got 2 transceivers left and 100 gigabit NIC, and that actually will work out pretty good here as long as I don't burn out another one of these. And we're going to be putting together the 5955WX machine in that really cool Leon Lee case. That's going to be a really nice looking build. Right here we've got our 7995WX. Over there we've got our 7050. We've got our brand new storage server. We're going to be putting TrueNAS on, and we are going to smoke that shared storage. We've also got our little 3620, which is a surprising and really kind of actually cool. I think that's one of the best budget, really low budget PCs that I've ever had. And it can have that E3 Xeon and ECC RAM. Ooh, I like that a lot. We're going to be retiring the R720XD, the quad GPU rig. All of those rigs now have 100 gigabit Ethernet. And so make sure you hit like and subscribe because we're going to be doing some shared storage configuration and testing really soon, as soon as I get that TrueNAS box set up. And there's going to be a video on that also. So we got 2 really cool hardware videos coming up. I hope you're excited. I know I am. Be sure to hit that like and subscribe, and I will check you guys out next time.